Hi, and welcome back to the Implementing and Administering Cisco Solutions, the CCNA 200-301 video series course by EC Council. My name is Glenn Singh. In this video, we'll be taking a look at configuring and verifying VLANs. So let's dive on in. So you're probably wondering, what are VLANs? Well, to put simply, VLANs are virtual local area networks. So you're probably thinking, how can a VLAN exist in a physical network? So let's take a deeper look. So a VLAN is a virtual LAN which simply allows a segmentation of physical connection or physical connected components on switches to simply be logically divided. A virtual local area network, a VLAN, creates multiple subnets and smaller broadcast domains. VLANs can scale to entire layer 2 networks. However, it cannot scale beyond a router. The cool thing about VLAN is that it helps us segment the network on a per interface basis and isolate traffic. So, if this sounds a bit confusing, let's take a look at how we can implement VLANs, but let's take a look at a network topology. In this network, we have one actual network consisting of two switches, switch 1 and switch 2. We have a total of 8 devices. So therefore, if PC1 decides to send a broadcast into the network, the broadcast message will simply enter switch 1. Switch 1 will then forward that broadcast out of all interfaces. So which means PC2, 3, 4 will also get a broadcast. Switch 1 will forward it to switch 2. Switch 2 will forward it to PC 5, 6, 7, and 8. Now imagine that within your organization, there are probably hundreds of computers that are interconnected to your same physical network. Imagine that someone within the HR department, their computer broadcasts a message. This means that everyone within your organization will receive that broadcast. Also, think about this. Imagine if multiple devices are simultaneously broadcasting messages just randomly. That can simply affect your network. To reduce all these broadcast messages or to isolate them, it is highly recommended to create smaller broadcast domains. To put simply, what if we can create a logical network and put all the HR devices in that network? What if we can create another logical network and put all the sales teams' PCs on that network? All the IT department computers in a network, all the servers on a network. Now you may be thinking, we need to buy new switches and physically segment them. But that's the old way. The new way, we can simply configure virtual LANs inside of our switches. So let's take a look at this. What if PC1 belongs to, let's say, VLAN 10? And let's say this other computer belongs to VLAN 10. And this one here, and this one. So, which means that if this computer here decides to send a broadcast, well, who will get a broadcast? So let's take a look at this. This computer sends a broadcast into the network. It is received on switch 1. The broadcast will only be sent to devices that belong on the same VLAN. So therefore, PC3 will receive the broadcast because switch 1 will send it to PC3. This interface, the switch will send it across. Switch 2 will receive the message and only distribute it to PC6 and PC8. What about PC2? What if PC2 is on VLAN 20? PC4 is on VLAN 30. PC5 can be on VLAN 30, and let's say PC7 is on VLAN 20. Therefore, if PC2 sends a broadcast, who will get the message? Well, this means that only devices that belong to the same VLAN will receive that message. Therefore, PC7 will receive the broadcast that is sent from PC2. Likewise, if PC4, which is on VLAN 30, sends a broadcast, who will get a message? Only PC5. The cool thing about using VLANs is the broadcast messages remain within their own virtual network, so therefore it does not affect any other devices that are physically connected to the same or to other interconnected physical switches. This here is a better example to simply show that you can have a single switch and multiple VLANs existing on it. As you can see that VLAN 10 is assigned to fast Ethernet 01, VLAN 10 is also assigned to fast Ethernet 02 and fast Ethernet 05. So which means if PC1 sends a broadcast, only PC3 and PC5 will receive that message. PC2 and PC4 belongs to VLAN 20. So therefore PC2 and PC4 will remain unaffected. So as you can see that the segmentation takes effect logically within the switch network itself. When a PC sends a message into a switch, the switch inserts an IEEE 802.1q tag. This IEEE 802.1q tag simply contains the VLAN ID. So let's imagine that we have a switch, and let's think about a switch. Let's say this here is a switch, and let's assume that on port 1 we have PC1 connected, but this interface here is configured with, let's say, VLAN 10. So when PC1 sends a message such as a frame into this first interface, the frame, once it enters the switch port, the switch will insert this IEEE 802.1q tag. This tag will contain the VLAN ID as 10. And this tag remains as long as the frame is inside the switch network. The only time a switch will remove this tag, it is only that if the switch is sending it to an end device. But for all times, the tag remains as long as it is inside the switch network. There are many benefits of using VLANs. One important benefit is VLANs allows you to improve the security. Simply, if an attacker connects to a particular interface on the switch, the attacker is only connected to that specific VLAN. Therefore, an unskilled hacker or an unskilled threat actor may think he or she has compromised the entire network, but only has access to that VLAN itself. So imagine that a malicious user plugs his attacker laptop into the sales VLAN. Well, of course the network is compromised, but if that attacker decides to do, let's say, a man-in-the-middle attack or probably generate some sort of broadcast storm, only the devices within the sales network will be affected. All other VLANs will remain unaffected. An additional benefit is it reduces the cost for network infrastructure. Simply that you can create multiple VLANs within a single physical network. This means you can have a VLAN dedicated for your voice network, while another VLAN dedicated for your video network. You can have multiple VLANs that exist for each department as well. By creating VLANs, we got a third benefit, which is it improves network performance simply because it creates smaller broadcast domains, which is the fourth benefit actually. The fifth benefit, it improves IT efficiency and management. A network administrator can simply log into a Cisco switch and reassign a port to a specific VLAN without having to physically move the end device, simply to log in and reconfigure the port with a new VLAN ID. On a network, you can find many types of VLANs. One type of VLAN is called a data VLAN. The data VLAN, as the name says, is usually configured to transport traffic generated by end devices, such as computers, servers, printers, even wireless access points. Data VLANs typically transport data. On all Cisco switches exists a very special VLAN called the default VLAN. The default VLAN is a primary VLAN which is loaded onto a managed Cisco switch after it has booted up. With a default VLAN, a new out-of-box switch normally has all of its interfaces or all of its ports assigned to VLAN 1 by default. This means if you connect multiple devices to any number of ports, as in any number of physical ports on the switch, by default, all devices will be able to communicate with each other. Another important VLAN is called a native VLAN. The native VLAN is used to transport or carry untagged traffic on an IEEE 802.1q trunk links. Trunk links exist between switches and between a switch to a router. However, end devices such as computers will send traffic into the switch, and the receiving switch port inserts an IEEE 802.1q tag, which is a VLAN ID, into the switch, and this type of traffic is called tag traffic. So where does untagged traffic comes from? Well, untagged traffic does not originate from, let's say, a switch port. So untagged traffic, to put simply, is self-generated traffic from the switch themselves. An example of untagged traffic is Cisco Discovery Protocol or CDP messages. The thing about a native VLAN is the native VLAN is very specific, simply that it is used to transport untagged traffic. But don't worry, we'll take a look at configuring the native VLAN when we are configuring trunking. Another type of VLAN is called a management VLAN. The management VLAN is used to remotely access a switch over a network. To put simply, this is also known as a switch virtual interface, an SVI. This simply allows us to place an IP address on a switch that allows us, the network engineer, to remotely access and manage that device. A network administrator can use HTTP, HTTPS, Telnet, or even SSH to remotely connect to the switch's IP address. When you work in a collaboration environment, you'll be familiar with something known as a voice VLAN. The voice VLAN, or to put simply, voice traffic, uses the UDP protocol, which is a user datagram protocol. And the thing about UDP, it does not provide any sort of reliability or guarantee of delivery of packets. Since a converged network is the most recommended type of network infrastructure, having a dedicated network for all voice traffic is highly recommended. Now, it doesn't make sense to create a whole physical network for your voice traffic, but we can create a voice VLAN within our existing network infrastructure simply by creating a voice VLAN for the voice traffic. This will ensure all the voice traffic is kept separated from all other traffic types on the physical network. When it comes to VLANs, we have two ranges. There's a normal range. The normal range exists from VLAN 1 to VLAN 1005. However, VLAN 1002 to 1005 are reserved for token ring and FDDI VLANs, so we cannot use them. VLANs 1 and 1002 to 1005 are automatically created by the Cisco switches and we cannot remove it. The VLAN configurations for the normal range are stored within a very special file. This is known as a VLAN database file, and it is referred to as the VLAN.dat. The VLAN.dat file is stored in the flash memory of the Cisco switch. Simply by using the command show flash : on a Cisco iOS switch will allow you to see the contents of the VLAN.dat file. The extended range simply exists from VLAN 1006 to 4094. The extended range VLAN configurations are not written to the VLAN.dat file, but they are written by default to the running config file. However, one disadvantage is that there are less supported features in the extended range as compared to the normal range VLANs. Some key important points to always remember when it comes to VLAN. All ports are assigned to VLAN 1 by default. The native VLAN is VLAN 1 by default. The management VLAN is VLAN 1 by default. And most importantly, VLAN 1 cannot be deleted, nor it cannot be renamed. To get started with VLANs, you must first create a VLAN. We can use the command VLAN and specify the VLAN ID, which is a number. Cisco switches recognize VLAN simply by their VLAN ID or their VLAN number. For us humans, we can use the name command and specify a name. The name will simply tell us the purpose of this VLAN. We can use the command show VLAN brief to verify all the VLANs that exist on a switch, the VLAN names. As for VLAN 10, we have accounting. VLAN 15, we have HR. This command also shows the port assignments. So in other words, we can see all the ports here, which is on the switch, is actually allocated to VLAN 1. There are no ports allocated to VLAN 10 or even 15. To simply assign a port to a VLAN, we access interface mode. As you can see here, we use the command interface gigabit ethernet 1/0/1. Once we're in interface mode, we use the command switchout mode access. This will ensure the interface becomes an access port. Access ports allow us to connect end devices and also assign data VLANs to that interface. Once we enter the switchout mode access command, we can simply use the command switchout access VLAN, and let's say we use VLAN 10. This will simply assign this physical interface to VLAN 10. As a security measure, we can use the switchboard no negotiate command. The switchboard no negotiate command will prevent the interface from changing from an access interface. So therefore, by using these three commands in this sequence, we ensure the interface remains statically configured as an access interface that is assigned to VLAN 10. Once more, we can use a show VLAN brief command to verify any ports that is under a particular VLAN. So let's look at VLAN 10, which is the accounting VLAN. We can see it is active, and now we have gigabit ethernet 1/0/1 assigned to VLAN 10. Furthermore, we can use a show VLAN ID followed by the actual number of the VLAN to verify any sort of additional statuses for this VLAN. As we can see, for VLAN 10, it is called the accounting VLAN, it is active, and we have a single interface assigned to this VLAN. Furthermore, if you know the name of the VLAN, you can use a command show VLAN name followed by the name of the VLAN. Here we get the VLAN ID, which is 10, we get the name, accounting, the status as active, and the port or ports assigned under this VLAN. Another important command is a show interfaces, interface ID followed by switch port. This command allows you to see the administrative state and the operational state. It also helps you identify The access mode VLAN ID, we can see it is using VLAN 10. Well, it is assigned to VLAN 10, and VLAN 10 is accounting VLAN. To remove a VLAN, simply use the command no VLAN. I could specify the ID. So let's say you want to delete VLAN 10 from the network. Well, not from the network, but from the switch itself. You can say no VLAN and specify 10 and hit enter. This will simply remove the VLAN only from that switch. Additionally, you can delete the entire VLAN database from a switch simply by using the command delete VLAN.dat. Or you can specify delete /VLAN.dat. Please keep in mind, if you use the command delete flash and hit enter, you will delete everything from the flash memory, including the Cisco IOS. So please be very mindful when you want to delete or remove VLANs from your switches. Sometime configuring a VLAN or configuring VLANs on your network, you may run into some problems. So to troubleshoot VLANs, follow these essential steps. Check the IP addressing on all your devices, especially your end devices. Check the IP address, the subnet mask, even the default gateway. Furthermore, verify the VLAN assignment is properly configured on each switch port. To verify the VLAN assignments, you can use a show VLAN brief, the show interface ID with the switch port command. You can also use a show interfaces VLAN ID command. So to get a bit more familiar with configuring VLANs, let's take a look at doing a lab. So please visit my GitHub link. Ensure that you are in the code red CCNA 200-301 folder. Click on Domain 2 Network Access and simply download and open Lab 1 VLAN Trunking and Inter-VLAN Routing Lab. This lab will span across the next video, which is inter-switch connectivity. In other words, it's trunking, and also ensuring more than one VLANs are able to communicate together. But for this lab in this video, we are simply going to configure the VLANs on this network. So simply click and open with Cisco Packet Tracer. Once you have opened the lab, it will look like this. We have 6 end devices, PC 1, 2, 3, 4, 5, 6. And each of these PCs are actually configured to be, well, their IP addresses are configured to be on a unique VLAN. So to put simply, PC 1 will be on VLAN 10, PC 4 will also be on VLAN 10, PC 2 VLAN 20, PC 5 VLAN 20, PC 3 VLAN 30, and PC 6 VLAN 30. So simply by configuring the VLANs on this network, if PC 1 should send a broadcast, only PC 4 will get it. So the same concept applies. So to put simply, in this lab exercise, you will learn how to create VLANs, name VLANs, and assign access ports to corresponding VLANs. So let's dive in, and we can begin this process simply by clicking on switch 1. Once you click on switch 1, click on the CLI tab, and you can simply extend the window so you have better room to work with. Now that we are in user exec, let's use the enable command to go into privilege mode, and then we'll use the global configuration command, which is configure terminal, to access global config. Now that we are in global config, let us create our 4 VLANs, inclusive of VLAN 99 as our native VLAN. Now that we have created our 4 VLANs on switch 1, this process also needs to be repeated on all switches on our network. If a VLAN does not exist on a switch, the switch will not be able to forward, accept, or even accept traffic for that specific VLAN. But since we are already on switch 1, let us configure fast Ethernet 01 to be on VLAN 10, fast Ethernet 02 to be on VLAN 20, and fast Ethernet 03 to be assigned to VLAN 30. So, let us start. Now that we have configured our VLANs, let us verify if the VLANs exist and their port assignment. We can do this by using the show VLAN brief command, like so. And notice here, we have VLAN 10, 20, 30, and 99. We can also see the ports actually assigned to VLAN 10 and 20, and even 30 as expected. So now let us head over to switch 2, which is the middle switch here, to configure, well, not really configure, but to create the 4 VLANs that we need. Since this switch is not connected to any end device, we don't need to create any access ports. We simply need to only create the VLANs only. And of course, we can use the show VLAN command, well, the show VLAN brief command, to verify the VLAN has been created. And as expected, we have our 4 VLANs created. Let us move on to the other switch, switch 3. On switch 3, we'll have to create the VLANs and also assign the ports accordingly. The configurations on switch 1 and switch 3 will be the same only for creating the VLANs and assigning the access ports. Now let us configure our access ports accordingly to the diagram. Now that we have configured our interfaces, let us verify the interfaces are actually accurately assigned. We can do this by using the show VLAN brief command. And here we can see our 4 VLANs created, and we have our interfaces that are assigned to our corresponding VLANs. Ensure that you do a copy run start to save your configurations on all the switches before closing the lab, because you will need these configurations over the next few videos. In this video, we took a look at discussing and understanding the need for VLANs. You even saw how to implement VLANs on a Cisco network and learn how to verify the VLAN configurations. In the next video, we'll take a look at configuring and verifying inter-switch connectivity. I hope this video has been informative for you, and I hope to see you in the next one.